In the diagram, the points A, D, B, and C are on the circumference of the circle center O. And also given that OC is parallel to AB and that the size of angle AOB is 108 degrees, calculate the size of angle ACB, the size of angle BAC, and the size of angle ADB. So let's proceed and find the sizes of the angles. So at first, we want to find the size of angle ACB, which is this one here, okay? So if we look closely on our diagram, we can see that the angle ACB is subtended at the circumference by the arc AB, and also that the angle AOB is subtended by the same arc AB at the center of the circle. So they have a relationship of 1:2 because there's a theorem which says angle at center is 2 times angle at the circumference. So angle ACB equals half of angle AOB, which is this one at the center. So it means our angle ACB equals to half of 108 degrees, which is equal to 54 degrees. Okay, so let me write on our diagram the size of angle ACB, that's 54 degrees. Okay, so let us proceed and find the size of angle BAC. So angle BAC is this one here. Okay, so if we look closely on our diagram, OA and OB are radii. So triangle AOB is an isosceles triangle, hence the base angles, this one and this one here, are equal in size. So the sum of the angle at A and the angle at B here equals 180 degrees minus 108 degrees, and we get our answer as 72 degrees. Hence, the size of the angle at B there equals to the angle at A, which is equal to 72 degrees divided by 2, which will give us the angle at B there is equal to 36 degrees, as well as that angle at A also equals to 36 degrees. So let me write here that's here is 36 degrees, and this whole angle as well also 36 degrees, because they are base angles of an isosceles triangle, hence they are equal in size. Since OC is parallel to AB and they are joined by the radii OB, it means this angle of 36 degrees here at B is alternate to this one here, so they are equal. So it means here is 36 degrees. Okay. Also, if we look at our diagram, we can see that the angle BOC is subtended by the arc BC at the center. Okay, so the required angle, which is the angle BAC, which is this one here, is half of this angle at the center. Why? Because the angle BAC is subtended at the circumference by the same arc BC. Hence, it is equal to half of this one, which is equal to 18 degrees, based on the theorem which says angle center is 2 times the angle circumference, provided they are subtended by the same arc. Okay, let me write here. So angle BAC equals to half of angle BOC, which is half of 36 degrees. Okay, and this gives us 18 degrees as the size of angle BAC. Okay, let us proceed. Now we want to find the size of angle ADB. So angle ADB is this one here. Okay, if we look closely on our diagram, we can see that ADBC is a cyclic quadrilateral. Why? Because its 4 vertices lie on the circumference of the circle. There is a theorem which says that the opposite angles of a cyclic quadrilateral are supplementary, meaning they add up to 180 degrees. Okay, so this angle D here, which is ADB, is opposite this angle here, ACB. Okay, so the sum of these two angles is equal to 180 degrees. So for us to find the size of angle ADB, we subtract 54 degrees from 180 degrees. Okay, so ADB equals 180 degrees minus 54 degrees, and we get our answer is 126 degrees. So here ADB is 126 degrees in size. Okay, so let me write the theorem which I used here. Opposite angles of a cyclic quadrilateral are supplementary. Okay, so it simply means that the opposite angles add up to 180 degrees. Okay, so thank you guys for watching. Meet you in the next videos.